All right, lab 5 is on forces and Newton's laws. And to start off with part 1, Newton's first law would be motion. So with 50 Newtons applied, the box will start moving to the right, which would mean that displacement is becoming positive. And as you can tell on the speedometer, the meter is continuing to go up. So that means that your velocity is increasing. All right, and your acceleration would be constant. And that's basically what part 1 of Newton's first law is talking about. So basically, to summarize up part 1, when no force is applied to the box, it doesn't move. When there's a constant force applied to the box, it continues to increase, like this box. When there is force applied for a short amount of time, the box continues to move with a constant velocity, meaning the object remains in motion until any other forces are applied to it. And that's basically what would be in part 1. And if it would be going in the opposite direction, then your displacement would be negative, and it would still have increasing velocity, and your acceleration would be constant. And all right, going to part 2. Let's see, all right. This talks about Newton's second law. All right, and this is with the graph. So basically what this one is talking about is reaching max velocity at different mass. So with higher mass, it would take longer for an object to reach top speed because more force needs to be applied to the object. So to basically summarize part 2, the heavier the object is, the longer it would take. Let's see. The longer it would take for the object to reach max speed. Okay. All right. And as you can see on my, let me see. Just mess with this real quick. As you can see on the chart, it would take 200 kilograms, 40 seconds, rather than, 50 kilograms. Okay, going to part 3, the skateboard, which would be friction. All right. Okay. When you remove this, when you remove the ground, it would have less gravity because different objects, different surfaces have different amounts of friction. Okay. So basically, it would be a lot easier to push something on a surface without any friction on it. Let me see. So to summarize part 3, friction has to be a force because it causes the box to slow down and stop at certain points. And it also means that an opposite force is acting on an object. Okay, let's see. Okay. And that's basically what part 3 of this lab is about. It talks about friction with basically on ice. Okay. All right, part 4 would be a double cap on Newton's second law. And basically you would still use the same simulation, and you would apply force. You would apply 50 newtons. All right, let's see. You'd apply 50 newtons. So first you would apply 50, but on this one I'm on the wrong one. Let's see. Well, I'm gonna just explain off of what the thing said. Okay, so when you would apply 50 newtons, the box, it wouldn't move because the friction would counter the applied force. So you would increase the amount of newtons that you would apply to the object. And the same thing would happen to the box. It wouldn't move because the friction force and the applied force would still be equal. So then you would apply 150 newtons, which would cause the box to move a little bit because the applied force is a little greater than the friction force. And then by clicking sum of forces, you can tell that applying 150 newtons rather than 150 would be a greater chance of it moving, because 150 newtons is greater than the friction force. So on to summarize part 4. The net force can be split into 2 components, which would be X and Y values. And the sum of all forces, let me see. When the box is not moving, the sum of friction and applied force is 0. When the box moves, the applied force is greater than friction. Okay, so basically stating that the static friction has to be less than, well, you have to pass up your static friction for the box to be able to move, and then you have to pass up your friction. And let's see, I think that might be the last parts. Oh, part 5, okay. Friction in detail. This one is kind of a lot, so I didn't really like go through this and put it all down. So I'm gonna kind of explain. Let's see, 50 newtons to the crate. Let me see, reset this. Okay. To increase that range required, this start key starting. When the 50 newtons is applied to the crate, it doesn't move. Hold up, I don't know if I have this right. All right. It starts moving a little bit, but it really starts moving around 125. Or it starts moving between 0 and 50, but it starts moving a lot fast at like 125. Okay. And basically what this one is telling us is that